Hello. All right, we're going to talk about the law of sines in order to solve oblique triangles. So oblique triangles are any triangles that are not right triangles. So if you have right triangles, we've got lots of tools, right? The Pythagorean theorem, trig ratios, but they don't work for oblique triangles. So in particular, the ones we're going to be able to solve with the law of sines are angle side angle triangles, where we have the side in between two angles, or angle angle side, okay, where we have two angles and then a side. And we can also solve side-side angle triangles, and you'll see those are a real pain, okay? Those are the hard case, but we can do it. And we can solve all of these with the law of sines. And the thing I want you to notice, so in this case, this is really a special case. If we know two angles, we can find this third angle, right? So really this is like we know all the angles, and it's really just a case of this angle, angle, side, okay? The important thing is that we always have an angle and a side across from it. Or here we have an angle and a side across from it. Okay? Here we have an angle and the side across from it. That's the critical thing. If we have that, then we know we can use the law of sines to solve an oblique triangle. So let's derive the law of sines. You're not going to have to do this, but it's good to know where it comes from. So if we've got a triangle, so here we have alpha, beta, and gamma, we're calling our angles, and A is the side across from alpha, B is the side across from beta, and C is the side across from gamma, okay? And we even without the law of sines, we could solve this. We could just draw a height, right, for our in our triangle, and we could say, okay, well, sine of alpha is h over b, and sine of beta is h over a. And then we could solve for h just by multiplying by b or multiplying by a, right? And we could set these equal to each other. We could say b sine alpha equals a sine beta, right? And then we could divide through by a times b to get sine of alpha over a equals sine of beta over b. So sine of alpha divided by a, which is the side across from it, equals sine of beta over b, the side across from it. Okay. And we could do this, it was a little bit arbitrary where we chose to draw this height, right? We could draw the height to a different vertex and do the exact same thing to get similar ratios. Okay. So this is the idea of the law of sines. It's pretty easy to remember. This ratio for every triangle is always the same. The sine of an angle divided by the side across from it, the length of the side across from it, that ratio is the same, which is pretty cool. So here's just a formal statement of it, pretty much the same thing. Sine of alpha over A equals sine of beta over B equals sine of gamma over C. And obviously we could have it the other direction, we could invert everything, right? We could say this ratio, A over sine of alpha equals B over sine of beta equals C over sine of gamma, okay? And remember this ratio, this relationship, if we call it, we're calling our angles alpha, beta, and gamma, and A, B, and C, the sides across from the corresponding side or angle, okay? So let's just do an example. Let's move, I don't know why it shows my video on some screens and not others, but here I am. Let's solve this triangle. So what case do we have here? We know a side, and we have two angles. So we have angle, angle, side. So we could find this angle if we wanted to. And the key here is that we have a side and an angle across from it, right? We have that ratio, so we can use the law of sines. So let's solve. So we can say 10 divided by sine of 50 equals C divided by the sine of 30, right? This ratio equals that ratio. And now I just put it in our calculator. That's really all there is to it. So let's do it. And I'm in degree mode, so that's great. So 10, I don't know if you can see it. 10 times sine of 30 divided by sine of 50 is 6.275. So C equals 6.527. They just want it to the nearest tenth, whatever. All right, and so we could do the same thing for side B, right? We could figure out, we know this angle, if this is 50, this is 30, that angle is going to be 100. So we could choose either ratio. Let's just choose this because it's easy. We could say 10 over sine of 50 equals B divided by sine of 100. So 10 times sine of 100 divided by sine of 50. And I get that B equals 12.856. Does that seem reasonable? Yeah, if this is 10, this is 12.856, this is 6.5. Yeah, that seems like reasonable numbers. And we're done. Right, this third angle we could find just by subtracting from 100, and we could find the other two sides using the law of sines. We could use this for an application problem. So maybe we've got this an airplane, and they asked us, I guess they described this at the beginning of the section, they wanted the altitude of this airplane. Okay. So before we can really find that altitude, we know this base is 20 miles. We want to find that height. So something that might be good is if this is a right triangle. If we knew that this side A, then we could just use a trig ratio to find this height here. So let's solve for A. And let's see, can we do that? Well, we know this angle here is 15. This angle is 35. We can easily find that angle, right? And we have this side. So the case we have is angle, side, angle, right? So the way we're going to do this is if we found this angle here, we have a ratio, right? An angle with a side across from it. And then we could use that to this ratio here, this angle and the side across from that to find A. So let's see, if this is 35 and this is 15, I guess together that's 50. So this angle is 130, right? So I'm going to say 20.
Can I have the following teachers please come to the large conference room? Nick Stell, CP Martinez, Ms. Friedley, Mr. Sattler, Mr. Heiser.
Okay, I'm just going to keep going.
Ms. McElroy, Mr. Mayor, and Ms. Largent. Could you please come to the large conference room again, Mr. Stell?
Sorry about the
Mr. Martinez, Ms. Friedley, Mr. Sattler,
right. 20
Heiser,
divided by
McElroy,
sine of
Mr.
130
Mayor, and Ms. Largent to the large
is going to be
room,
A divided by sine of 35, right? This ratio and that ratio are going to be the same. So we just put in our calculator, 20 times sine of 35 divided by sine of 130 is, let's say, 15. A is about 15 miles. Okay, so if we know that that's 15, and we know that this is 50, and this angle is 15, let's find that height, right? So now it's not a law of sines problem, it's just a regular old, what's that height, right? Well, opposite and hypotenuse, so I'm going to say sine of 15 degrees equals h over 15 miles. And I guess I could use this exact value. This times sine of 15 is 3.84. So my height is about 3.84 miles. That seems believable, right? Okay, so yeah, in these cases where we have angle, side, angle, or side, angle, side, well, angle, side, angle, let's say, pretty straightforward to use the law of sines. Stay tuned for the next video. It gets more complicated.